Hi, 5th grade. It's Mrs. Gioka with your flipped math lesson for today, 8-9. Today's objective is I can solve problems using reasoning to supply information that I need. And today for our lesson, you're going to really be using reasoning, you're going to be using logic and what makes sense. And in addition to that, we're also going to be using some of the algebra that we've been learning, using those variables to make algebraic expressions. And we're actually going to go a step farther and change them from algebraic expressions into algebraic equations. An equation's a little different because it equals something. And we haven't done that yet. So our skills are going to advance. We're going to be doing something just a little bit more difficult than we've done before, but I am going to assure you, you're going to understand it and you're going to find that it's not that very difficult. Here's our first practice problem to work on together. A children's zoo displays birds in 3 different types of cages. The zoo has 3 kinds of birds. There are 36 birds in all. How many of each type of bird are there? Now you're missing a little bit of information here, so I'm going to show that to you on the next page, but I wanted to first underline the question that's asking us, well, how many of each type of bird are there? That's what we're going to figure out. And we know that there's 36 birds in all. And then the extra information I couldn't put on here is the picture. So here's the bird cages. And you can see in this yellow cage, there are 24 parakeets. Now, in the other 2 cages, it tells us that there are 3 times as many canaries as there are parrots, but it doesn't tell us how many there are exactly, okay? But we know that there's 36 altogether. We know that 24 of them are going to be parakeets. The rest are canaries and parrots, and there are 3 times as many canaries as there are parrots. Well, using reasoning, I know that I can already go ahead and start to figure out this problem. So far I've got 36 altogether. I know 24 of them are parakeets. So if I subtract 24 from 36, then I get 12. So 12 of them are left and 12 are going to be canaries and parrots. Then I have to figure out, well, how many canaries are there? How many parrots are there? So what I did is I drew this picture. So I knew that there are 24 parakeets, and then I added on there are 12 canaries and, oops, I made a mistake. There are 12 canaries and parrots, not parakeets. That was my mistake. Okay, so I know that when I add those together, then I get 36. Altogether, okay? So I've already got the parakeet information. I'm just going to worry about this information right there, that there are 12 canaries and parrots. Now, remember, there are 3 times as many canaries as there are parrots. And what we do in algebra, remember, when we come to an amount, we don't know exactly how much it is, we might put a letter. Okay, so for parrots, I'm going to put the letter P, and P is going to equal the amount of parrots that there are altogether. So parrots is going to equal P, and if the canaries, if there's 3 times as many canaries than there are parrots, well, that's the expression 3 times P. 3 times as many parrots, okay? Now remember, we can also write that another way. We could write it just 3P. We don't have to write it 3 times P. We can just write 3P, and that's a little bit easier to see with our eyes instead of having that X in there, because then we won't wonder if that X is a variable or if it's an operation, okay? So I know that 3 times the parrots equals the canaries, and when I add that to the amount of parrots that there are, altogether, that number is going to equal 12. And I know that because before, remember we said there are 12 canaries and parakeets because we subtracted the amount of parakeets from the total amount, 36. We know there's 12 left, and I know that P, the amount of parrots, plus 3P, or 3P plus P, is going to equal 12. Now, the funny thing that can happen when you have these variables, these letters, if you have a letter and you have the same letter someplace else, you can add them together. Okay, so I have 1P over here. It doesn't have the number 1, but it means the same thing. I have a P, which is just 1P plus the 3P. Okay, so if I add those together, that is 4P. Okay, and 4P is going to equal 12. Now this is an algebraic equation. What I can do now is I can divide, because remember I've got multiplication going on here. And if I divide 12 divided by 4, so if I divide it by 4, then I can, if I divide this also by 4, then it becomes just P. Okay, so like they cancel each other out. Okay, and I can get that P all by itself, and then I can think, well, 12 divided by 4 is 3. Okay, now I could look at my picture as well, and I can think, well, there are 3 times as many canaries as there are parrots. I wrote parakeets in there. So that must mean that, you know, that if I multiply, it's going to be a multiple of 12. Okay, and I can think of what my multiples of 12. Well, 1 is a multiple of 12, 2 is a multiple of 12, 3 is a multiple of 12, 4 is a multiple of 12, and 6 is a multiple of 12. And 3 times this number is plus the number is going to equal 12. So 3 times 3 plus 3 would equal 12. Okay, so I know that P equals 3. So I'm using reasoning to figure that out. So I figured out the amount of parrots is 3, the amount of canaries is 9, and the amount of parakeets is 24. Now this is the one they gave me, and I figured out that there are 3 parrots, and if there are 3 parrots, if the parrots equals 3, then the canaries, remember, it equals 3 times P. Well, 3 times 3 equals 9. Okay, and then I can plug them in and make sure that that all adds up. So 3 plus 9 equals 12, and 12 plus 24 equals 36, and there were 36 total. So that works. Okay, so that's using reasoning as well as using some models to figure out the answer. So we're going to be doing a couple of those problems today. So we're going to solve the problem. We're going to use reasoning and models to try to find the answer, as well as algebraic equations. So here's our first problem. The Barker family is donating 25 baseball caps to charity. There are 11 blue caps. There are 2 more white caps than green caps. How many of each color are there? So first look at the problem, see what it's asking us to do. We've got to find out how many of each color there are. And the important information we know is that there are 11 blue caps and that there are 2 more white than green caps. Okay, so we've already got some information. And I put it here and I kind of labeled each part. I know that there are 11 blue caps. The green, I don't know exactly how many are, but the white, I know that there are 2 more than there are green. And I know that there are 25 total. Okay, so what I can do is already start to solve my problem by taking the 25 and subtracting the 11 to see how many there are left. And I see that that means that there are 14 green and white caps left. Okay, so here I've drawn my picture. There are 11 blue. I know that there's 14 white and green. Well, remember, there are 2 more white than there are green caps. So what I did is I took my picture of 14 caps and I said, well, 2 of them have to be white because there's 2 more that are white than there are green. So the rest of them that are left, those are an equal amount of green and white. So I could just split them down the middle or divide it by 2, and then I would know that this amount is the white and that amount is the green. There are 12 of them. I know that 12 divided by 2 equals 6. So there are 6 green, and there must be 6 plus 2, remember the 2 more that are white, that 6 plus 2 is 8. So there must be 8 white caps. Okay? So I knew that there were 11 blue ones. I figured out there are 6 green ones. And then 6 plus 2 more would equal 8 white caps. And if I add that all together, I get 6 plus 8 equals 14. And then 14 plus 11 equals 25. There were 25 caps total. So I double checked to make sure that it worked. Alright, so that's using reasoning to figure out the answer. You're going to try a few and see how it works for you. Now, before I do that, what I could have done is I could have made an algebraic equation to also help me figure out my answer. Okay, I'm going to go back and show that to you so that if you would like to try that when you're solving the problems, that would work for you as well. Okay, so I know that there are 25 hats altogether. I knew that 11 of them were blue, plus an amount that was green. I don't know how many green, so I'm going to put the variable g to show the green ones. And I knew that there were some that were white, right? And it's going to be 2 more than there are green, which is the same thing as green plus 2. Okay, so this G plus 2, what that really stands for is the white caps. Okay, now remember I told you that when you have letters that are the same letter, you can add them together. So if I have a G plus another G, that equals 2G. Okay, and then I write the rest of the problem around it. Whoops. Get back there. Okay, so now I've got 25 equals 11 plus 2g plus 2. Using my order of operations, I would know that if I had multiplication or division, that would come first, but I don't have any of that. All I have is addition here. So I can add these numbers together, the ones that are not the g, I'm going to add those together. So 11 plus 2 would equal 13. So now I've got 25 equals 2g plus 13. Now this is where algebra becomes kind of like a teeter-totter. So I imagine that the equal sign is the fulcrum of a teeter-totter, and whatever I do on the right side, I got to do on the left side. Whatever I do on the left side, I'm going to do on the right side. So I've got plus 13. I'm going to subtract 13 to get rid of that. If I subtract it from this side, I've got to subtract it from this side. Okay, so 25 minus 13 is 12. And 12 will now equal 2g. What I'm doing right here with the 2 and the g is really multiplication, 2 times g. To get rid of the 2, I'm going to do the inverse operation, the opposite. So I'm going to divide it by 2. And then that cancels out the 2. And if I do it on one side, I have to do it on the other. So 12 divided by 2 is 6. So G equals 6. Okay, so if I know that G equals 6, then 2 more than green, or 2 more than G would equal 8. Okay, so that's using algebra. Now, if that doesn't make sense to you, then don't worry about it. Don't try it. Just use your reasoning and use your models to help you figure out the answer. Okay, but if that made sense to you, you can give it a try. Oops. Yeah, that was number 1. All right, number 2. This time I'm going to hush and I want you to solve the problem and see if you can find the answer, and then we will come back and see if you got it. Okay? Here's the problem. Mr. Niles has a box of accessories for clarinets. He has a total of 42 objects. He has 12 mouthpieces. He has 4 times as many reeds as neck straps. How many of each object does he have? Okay, try to solve the problem, pause the video, and then come back and see if you got it right. Okay, so I'm looking for, what is it asking me? Well, it wants to know how many of each object does he have. Important information I already know is that he has a total of 42 objects. 12 of them are mouthpieces. There are 4 times as many reeds as neck straps. Okay, all that's important. What I already know is that there are 42 total and that he has 12 mouthpieces. So that leaves me with 30 reeds and neck straps. Okay, I know that he has 3 times as many reeds as he has neck straps. So I don't know exactly how many neck straps he has, but I do know that he has 3 times as many of that equal reeds. Okay, so I'm going to put N for neck straps. I'm going to put 3N for the reeds. Okay, because 3 times the neck straps equals the amount of reeds. And then, so there's going to be 30 altogether of the neck straps and reeds. 3N plus N is going to equal that amount. Okay, so I wrote it again over here. The neck straps equals N. Reeds will equal 4N because there's 4 times as many of them. When I add them together, N plus 4N, that's going to equal 30. Remember, if we have letters that are the same letter, then you can add them together. So if I had 1N and then I had 4 more N's, that equals 5N. And 5N is going to equal 30. Now remember, 5N means 5 times N. Okay, to get rid of the 5, I'm going to divide. I'm going to do the inverse operation, the opposite thing. I'm going to divide it by 5, and when I do that, it cancels it out because 5 divided by 5 is 1. And when you have 1 next to a number, or I'm sorry, a variable, you don't have to put the 1. Okay, we never ever do that. We just put the letter. Okay, so I don't have to put 1 in, I just put N. Now if I do it on the left side, I've got to do it on the right side, like a teeter-totter. Okay, so I'm going to divide 30 divided by 5. And you can tell it looks like a fraction, doesn't it? Because fractions are really division. But that just means divided. 30 divided by 5 is 6. So I know that N equals 6. Now let's see if that works. 6 plus 4N, well, that'd be 4 times N, and if 6 is N, that'd be 4 times 6, and that's 24. 6 plus 24 does equal 30. Okay, so I know that my problem works. Whoops, or I know that 6 works. Okay, so then altogether I would have 12 mouthpieces, and I'd have 6 neck pieces, and then I would have 24. Is that right? Yep, 24 reeds. Okay, and then add that all up to make sure that we got the amount 42 that we started with. So we've got 12 plus 6, that equals 18. Then I had 24 reeds. 4 plus 8 is 12. Carry the 1. And that equals 42. And that is the total that I started with. Okay, so that works. Let's try another one. Number 3. Emily has a collection of bracelets, necklaces, and earrings. She has 16 bracelets. The number of earrings is 2 times the number of necklaces. Write an expression that shows how many she has in all. So the first part, I want you to just write an expression that shows how many she has in all. Okay, so we don't know how many she has in all right now. All we do know is that she has 16 bracelets, and we know that she has 2 times as many earrings as she has necklaces. So we know that 16 plus a number of necklaces plus, we know that the earrings is 2 times that amount of necklaces. And that's all we know so far. Okay, so that would be the expression, the algebraic expression. So that's the first part of the question. So here's the next part of the question. If Emily has 43 pieces of jewelry in all, how many of each type does she have? See if you can solve that one. How many does she have of each type? Okay, so what I did is I took my algebraic expression, 16 plus n plus 2n, and I just made that equal 43. So that's the only thing that's different. Okay, so now remember, when we have letters, we can add them together if they're the same letter. So I can simplify my problem a little bit and say that 16 plus 3n, because n plus 2n would equal 3n, equals 43. Okay, now since I know that there's 16, I could subtract that. So I'm going to subtract it from this side. Okay, and now I have 3n, because that would be 0, right? You don't have to write 0 plus 3n, you just leave the 0 off. And then I'm going to subtract it from this side as well. Okay, remember, it's like a teeter-totter. Whatever I do on one side, I have to do to the other side. So 43 minus 16. Well, I'm going to have to borrow. 13 minus 6 is 7. 3 minus 1 is 2. Okay, now I have 3n equals 27. I know that this is multiplication, so I'm going to do the inverse operation, the opposite operation, to get rid of it. So I've got 3n divided by 3. That's going to equal n. And then I've got 27. I'm going to divide it by 3 also, because if I do it on one side, I have to do it to the other. So 27 divided by 3 is 9. Okay, so there are 9n, or 9 necklaces. Okay, so I know that the necklaces equals 9. That was that part. There are 2 times as many of that, so that means the earrings equal 2 times 9 is 18. And then I already knew that there were 16 bracelets. Okay, and I'm going to add that all up and see if it equals 43. So I'm going to make some room over here. Make sure it all works out. So 9 plus 18. 9 plus 8 is 17. We got 27. And 27 plus 16. 7 plus 6 is 13. Carry the 1. 2 plus 1 is 4. So 43 matches 43 right there. So we got the right answer. Okay, so I hope you did it well. If you did not, don't worry about it. This is not going to be on the test. This is kind of advanced. Okay, all right, so we are finished for today. Good job. I will see you tomorrow. Bye-bye.